Hello everyone, welcome to another video. All right, today we have this question about rotational motion. Okay, now we have the question reads: a dentist drill starts from rest after 3.20 seconds of constant angular acceleration. It turns at a rate of 2.51 times 10 raised to the fourth revolution per minute. Okay, now we want to find the drill's angular acceleration and also to determine the angle in radians through which the drill rotates during this period. Okay, now it is important to know that rotational motion is an important part of everyday life. You know, like when we talk about the rotation of the earth, which bring about, the cycle of day and night. That is, it creates the cycle of day and night. Then also when we talk about rotation of wheels, which enable easy vehicular motion. Then also rotational motion, okay, that's based on modern technology. Also depends on, that's when we talk about rotational motion. Modern technology also depends on what we call circular motion in a variety of contexts. And that's why when we talk about rotational motion, take the case of a car, okay, moving around a circular racetrack. Like when we have a car, okay, moving around a circular racetrack. A car moving around a circular racetrack. Okay, let's say we have a car moving around a circular racetrack. That means we have a car, okay, that just like we have a car making a U-turn, or a car describing a circle along its path. That's when a car makes, that is motion of a car turnings. We can also put it that way. That means as a car is making a turn, okay, it will be describing a motion along its path. Then another example is when we talk about clusters of galaxies, orbiting a common center, just like the case of satellite, for example. Now if you want to talk about, without circular motion, that's without centripetal force, circular motion cannot occur. Yes. Then there's this other one again that it is also important. Rotational motion, when combined with Newton's law of universal gravitation and his laws of motion, can also explain what we call, it can also explain some facts about space travel, yeah, and also what we call satellite rotation, such as where to place a satellite, okay, where to place a satellite, so that it will remain in a fixed or constant position over a spot, on the earth. That is where to place a satellite on earth. That's where it must be placed, okay, so that it can remain in a what? In a fixed position over a spot, on the earth. Now that's one of the applications of rotational motion. So now we have this question. So it reads: a dentist drill starts from rest after 3.20 seconds of constant angular acceleration. It turns at a rate of 2.51 times 10 raised to the fourth revolution per minute. Now we want to find the drill's angular acceleration and also to determine the angle in radians through which the drill rotates during this period. Okay, now to be able to calculate the drill's angular acceleration, now this is very important. Now we have in the question that a dentist drill starts from rest. When we say a dentist drill starts from rest, it means the drill's initial angular speed will be what? 0. After 3.20 seconds of constant angular acceleration. So which means the time in this case will be what? 3.20 seconds, okay, of constant angular acceleration. Now, what is missing here is the angular acceleration, okay. Now, it turns at a rate of 2.51 multiplied by 10 raised to the fourth revolution per minute. Okay, now we're given the angular speed, which is the final angular speed. to be 2.51, okay, times 10 raised to the fourth revolution per minute. Now, we need to convert this speed, I mean the initial, that's the final angular speed, into rad per seconds. Now, it is important to note that one revolution is equals to 2 pi, just like 2 pi radians, okay, and which is equals to what? 360 degrees. Then also, we know that 1 minute, okay, equals to what? 60 seconds. So which means to convert the final angular speed into radians per seconds, okay? Now let's convert W, which is the final angular speed, into what? Into rad per what? Per second. So we have the final angular speed to be 2.51 multiplied by 10 raised to the fourth. Now we have here, so this is same thing as 1 multiplied by 1 revolution over what? 1 minute. So this will be 2.51 multiplied by 10 raised to the fourth. Okay, 1 revolution. We have 1 revolution to be what? 2 pi. Okay, and that becomes what? Rad. Because 1 revolution equals to 2 pi radians. Then over 1 minute equals to 60 seconds. So we have 60 seconds. Okay, so which means the final angular speed will then be what we get from what is 2.51 multiplied by 2, then multiplied by the value of pi. Okay, then so that will be 15.773 multiplied by 10 raised to the fourth divided by 60. So when we divide this by 60, that will be 0.262629. So the angular, that's the final angular speed, is 0.26, okay, 2629 multiplied by 10 raised to the fourth, which we can also write to, which can also be what? 2.63 when we what? When we round this up. So we have 2.63 times 10 raised to the power of what? -1. Okay. Now when added to 4, it will be what? 3. So this will be in rad per seconds. So this is the final angular speed. So, and we know that without knowing the final angular speed, we won't be able to calculate the what? The drill's angular acceleration. So to be able to calculate the drill's angular acceleration, now we want to calculate the drill's angular acceleration, which is what is missing. Okay. Now we know that angular acceleration measures change in angular velocity with respect to time. Okay, that is, or the rate of change of angular velocity. So in this case, we know that angular acceleration is change in angular speed over what? Over time. And we know that change in W, that is the angular speed, is the final angular speed negative the what? Initial angular speed. So we can then write this to be W negative W naught over what? Over T. Now we know the value of W naught to be what? 0, which is the initial angular speed. So we have the angular acceleration to be, now the value of the final angular speed, which is 2.63 times 10 raised to the fourth, 10 raised to the third, okay, minus 0 all over time t. Now the time is 3.20, okay, so that this will be 2.63 over 3.20 multiplied by 10 raised to the third. Now 2.63 divided by 3.20, that will be 0.8219 multiplied by 10 raised to the third, and this will be in radians per square seconds, and that will be, this is going to be 8.219, okay, multiplied by 8.219 multiplied by 10 raised to the -1, then times 10 raised to the third in radians per square seconds. So the angular, that's the drill's angular acceleration, will now be 8.219 multiplied by 10 raised to the second in radian per square seconds. All right, so this is the angular acceleration of the drill. All right, so the second question. Now we want to determine the angle in rad or radians through which the drill rotates during this period. Now that is the angular displacement. You know, angular displacement measures the what? It measures the product of angular speed and time. All right. So in this case, then also we can also write another equation for angular displacement. We know that angular displacement will be equals to the initial angular velocity multiplied by time plus 1/2 of angular acceleration then multiplied by what? T square. Okay, now we know the value for angular, that's the initial angular speed to be what? 0. And we have the value of the what? Angular acceleration. We have the value of the angular acceleration to be 8.219 times 10 raised to the power of 2 rad per square seconds. Okay, so the time remains 3.20 seconds. So that this will be the angular displacement, which is the angle through which the drill rotates during this period, will then be 1/2 multiplied by 8.219 times 10 raised to the second, okay, then multiply by 3.2 raised to the what? Power of 2. Okay, so let's divide 8.219. Okay, let's divide it by 2. Now that will be, so we're going to have angular displacement to be 4.1095 multiplied by 10 raised to the second. Okay, then also what is 3.2 to the square? That will be 10.24. So we have 10.24. Okay, so let's multiply 10.24, okay, multiplied by 100, then multiply by 4.1095. 4.1095. So this here we have 4208.128. So we can approximate this to be 4208, rad. And this is the what? This is the angular displacement. Okay, the angular displacement or the angle in rad through which the drill rotates during this period. The noblest pleasure is the joy of understanding. Bye bye.